Welcome to the exam question walkthrough for the energy topic. So let's make a start. Question 1. 10 joules of work is done lifting a ball at a distance of 1.8 meters. How much force was used to lift the ball? So this equation, we need to use the very basic definition of work done or energy transferred, which is force times distance. So 10 joules of work was done. What is the force if it was moved 1.8 meters? Obviously, we can rearrange that. 10 divided by 1.8 equals 5.6 newtons, which means that the answer is C. And 2, this graph shows the relationship between mass and weight on two different planets. So this is something that you've looked at in year 7 and would have looked at again in year 9. The weight of an object on planet X is 3 newtons. So planet X is 3 newtons here. What is the weight of the same object on planet Y? So what are we going to do? Well, a weight of 3 Newton corresponds to a mass of 4 kilograms. So on planet Y, 4 kilograms is going to be 2 newtons. So the answer is B. Okay, question 3. Molly pulls toy cars along the floor in a laboratory. She measures the force and distance moved each time. The results are shown in the table below. Which 2 cars took the same amount of work to pull? So again, what equation is important? Work done equals force times distance. So which have the same? So A, 10 times 2 is 20. So A is 20 joules. We'll just write this down to keep a record. B, 5 times 6 is 30 joules. C, 4 times 5 is 20 joules. Well, there we go. A and C. And 2 times 7 is obviously 14. So all right. In an experiment to look at work done, Molly uses electric motors to lift a large mass to find out which motor is the most efficient. She measures input and output electrical energy to calculate the work done on the mass. Look at the table of her results. She says, I think that motor Q wastes half as much energy as motor R, so Q is the most efficient. Molly's statement is partly correct and partly wrong. Use the data and calculations to explain why. Okay, so let's look at Q. So efficiency equals useful energy divided by total energy. So the useful energy is 760. The total energy is 800. So what's the efficiency? The efficiency is 0.95 or 95%. Let's look at R. So efficiency equals useful energy divided by total energy, which equals 1920 divided by 2000, which is 0.96 or 96%. So Q is not the most efficient, R is. So which bit of a statement is correct? I think that motor Q wastes half as much energy as R. So let's look at Q again. So wasted equals total minus useful, which is 800 minus 760, which is 40 joules. Let's look at R. So wasted is total minus useful, which is 2000 minus 1920, which is 80 joules. So she is correct about Q does waste half as much as R. So she is both correct and incorrect. All right, part C. Motor R takes 20 seconds to lift the mass. Calculate the difference between the input and output power. So input, actually firstly power, is the rate of transfer of energy. Whenever you see rate, it means divided by time. So energy divided by time. So let's look at the input. So for motor R, what's the input? It's 2000. So 2000 divided by 20 equals 100 watts. Output 1920 divided by 20 equals 96 watts. So the difference equals 4 watts. Okay, so as long as you write down these formulas, super easy. As long as you write down you're working out, super easy. All right, question 4. We'll just get it all on the same page. Deng is a weightlifter. She lifts 6 different weights. She plots the graph, which shows the distance and the weight. The table shows the amount of time she takes to lift each of the 6 weights. Deng does work lifting each weight. The speed she lifts the weight shows how powerful she is, which is Ding's most powerful lift. So we know that power is energy divided by time. Which one of these has the most energy? Well, energy is force times distance. So because we've got work done equals force times distance. So which one has the most work? It's obviously going to be F. But does F... Oops, sorry, I'm just going to make this a bit smaller. Can I make 2 on one page? No, I can't. All right. So F is 750 times by 1.6. 750 times by 1.6, which is 1,200 joules. And what's her power? The power is 1,200 divided by 3.6, which is 333 watts. So let's check one of these ones and see what's going on. So let's look at C. 275 times by 1.5. So C, 275 times by 1.5 equals 412 joules. And then what's the power? 412 C divided by 4.2 is 98 watts. Okay, so that is much, much less. All right, let's just try one more. Let's try this one here. No, actually, let's try E. We'll try E just because it's got the next kind of smallest time. So let's look at E. We've got 550, 600, 625 times by 0.6. Which is 375 joules, and 375 divided by 3.6. I mean, that's obviously not going to be very much. I think we can stop doing these calculations now because it's obvious that F is far greater than everything else. So the answer is obviously F. And we've done some calculations here. We've worked out the work done and the power, and we've shown that F is far greater than the other ones. And it's kind of obvious because it's so far above on the graph. All right, question 6. Let's get it all. Oops, get it all on one page. This question is about gravitational potential energy and kinetic energy. Look at the diagram and information about a small ball falling from a height of 20 meters. Explain the changes in GPE and KE and describe what would happen to the GPE and KE if the mass and ball was doubled. So, as the ball falls, GPE turns to KE. It's okay to use abbreviations because they've used it in the question. All right, so 100 joules of GPE transfers to 100 joules of Ke. All right, it's conservation of energy. Halfway up, we have transferred half of the energy. So exactly half is GPE and half is Ke. All right, so here, for example, half, this is half. All right, you can see what's happening. So I think that's probably enough to explain the energy transfers. GP, what's the formula for GPE? It's mass times gravitational field strength times height. So if we double the mass, the GPE will double. What will happen to the kinetic energy? Well, you can never have more kinetic energy than you had GPE. So whatever you start with GPE is the most kinetic energy you can ever have because all of the GPE is just going into kinetic energy. So if you double the mass and have double the GPE, you will also have double the kinetic energy. Now you might want me to show you a formula. I think that is enough. I mean, we've got 6 points here. It is a 6-mark question, so we've got enough. You might want to know what kinetic energy is. Equals a half times mass times velocity squared. All right. If you double the mass here, then you can obviously see that we're going to be doubling the kinetic energy. So that is okay with the maths, but we don't really need that. These parts here are enough for 6 marks. Okay, question 6. Taran's friend Charlie has a van. Charlie's van has double the mass of Taran's old car. Charlie says, when my van goes twice the speed of your car, it will have 4 times as much kinetic energy. Is Charlie correct? So let's get our formula for kinetic energy that we just typed. All right, this is what we of course need to write down first. So Charlie's van has double the mass. So let's do Charlie's van. So if we double the mass, we're going to have 2 times the mass. But if it goes twice the speed, what's going to happen? So 2 times velocity. Okay. So let's actually, we'll just simplify this. Instead of the words, we'll just have the symbols because it will make it slightly easier. Okay, so we've doubled the mass, we've times the velocity by 2. So what's going to happen? Oops. What's going to happen? We're going to have a half times 2 is just 1. So it's just going to be m. 2 squared is 4. and v squared is obviously v squared. So we're going to have m times by 4 times by v squared. If we write it in a slightly more normal format, 4mv squared. So that is actually correct, isn't it? Charlie is correct. Charlie is correct. His van or her van will have 4 times as much KE. Oh, my typing is really bad. Apologies. All right, and if you want to know why, all you have to do is look at this maths here. So if you double the velocity, kinetic energy times by a factor of 2. Actually, no, sorry, hang on. I made a silly mistake here, haven't I? Very silly mistake. Charlie is not correct. His van won't have 4 times as much, have 8 times as much. Because, of course, what's 4 divided by a half? Well, of course, that equals 8. So actually, because we've got rid of this half, so it's 8 times as much. So Charlie is actually incorrect. Silly, Mr. Simon. All right, 7. Nadine is performing some experiments about infrared radiation. Look at the diagram of the equipment she uses. It shows 4 identical flasks full of water at different temperatures. The flasks are all painted with the same black paint. Which flask gives out the most infrared radiation? So things that are hotter cool down the fastest because they're giving out the most heat. So which is the hottest? It's D. So the answer for this is D because it's the hottest. Nadine then uses 4 identical flasks of different colours. Each of them starts at 60 degrees. The list shows the colour of her flasks. Put a tick in the box next to the flask which cools down the quickest. So we need to know that black surfaces emit more than white surfaces. And we need to know that dull surfaces emit more than shiny surfaces. So it's going to be one of these two. Silver is obviously shiny, and it's going to be dull black. Okay, so dull black answer. All right, question 8. Let's just put it all on one page. Student measures the extension of a spring when it is stretched. He hangs different cubes from the spring. He measures the extension of the spring for each cubed. Look at his results. Plot the results of the graph on the grid. We can't do that. What we can do, use the results on the graph to show the spring constant is 35 newtons per meter. Now, we haven't done this since year 7, but it doesn't matter because it's really easy to work out from the information it's given. Okay. So I put this question in here just to show you that if you ever get something that looks a bit unfamiliar, you can probably work it out from what's given to you in the question, or it might just be a case of using a formula that's on the formula sheet or that you already know. All right. Obviously, nothing's going to be in the test that you can't answer. So the spring constant is 35 newtons per meter. So that means newtons divided by meter. So what we need to do is we need to take the newtons, we need to divide it by the meters. So if we take 7 newtons and we divide it by meters, we get the spring constant. Now, we've got 20 here, but that's 20 centimeters. We don't want 20 centimeters, do we? We want it in meters. We need to divide by 100 to get 0.2 meters. So 7 divided by 0.2 equals 35. Okay, so if a question like this came up, right, you just need to read the information in the question, use the clues that's given where it tells you what the spring constant is, force divided by meters. If it said work out the energy in a spring, then you look at the formula sheet and you plug the numbers in to the equation. Right, so you wouldn't actually need to know anything at all. You just use the equation that's given. So that, I believe, is the end. Oh no, we've got a couple more. And that's counted. All right, question 9. Car travels at 10 meters per second. Mass of the car is 800 kilograms. Use the equation. Kinetic energy is half times mass times speed squared, or velocity squared. Calculate the kinetic energy of the car. So let's type in all the numbers. 0.5 times by 800 times by 10 squared, which gives us 40,000 joules, which is C. Super easy. Question 10. A teacher adds 200 centimeters cubed of warm water to a beaker. He wraps the beaker in insulation. He measures the temperature drop after 10 minutes. The table shows the results of 4 different experiments, A, B, C, and D. Which experiment gives the lowest rate of cooling? So, firstly, we've got thermal conductivity or relative thermal conductivity. So, thermal means heat. Conductivity means, how much does it conduct? How much does it transfer heat? So, a greater number means it transfers heat more, and a smaller number means it transfers heat the least. So it's probably going to be either A or B. The thickness of insulation, what is insulation going to do to the rate of cooling? It's obviously going to slow it down. So the thicker the insulation, the lower the rate of cooling. So here we want the slowest rate of conductivity of heat and the thickest insulation, which gives B. Question 11. There is a temperature change of 3 degrees Celsius in the room. This is caused by the radiator giving out 18,900 joules of energy each second. The heat capacity of water is 4,200 joules per kilogram per degree Celsius. Calculate the mass of water flowing through the radiator to cause it to give out 18,900 joules of energy each second. So we need to know the heat capacity equation. So it is on the formula sheet. Energy transferred equals mass times specific heat capacity times temperature change. Okay, so the energy is 18,900 joules. Mass is what we're trying to work out. The heat capacity is 4,200 joules per kilogram per degree Celsius, and the temperature change is 3. So now we can solve this equation. So 18,900 is going to be equal to our mass, which we're trying to work out, times by 4,200 times by 3, which is 12,600. So now we need to divide 18,900 divided by 12,600 to get the mass, which equals 1.5 kilograms. Okay, so again, if you write out the equation of the formula sheet like this, and you fill in all the numbers you know underneath, and you either write X or mass or question mark for the thing you don't know, write out the working like this. Super easy. You will get all the marks, and that's 3 marks. Well, actually, it's 2 marks, but often it's 3 marks for exactly the same question. All right, final question. Sam wants to reduce his energy costs. He fits a wind generator to his house. The generator produces 1.8 kilowatt hours of energy each day, 24 hours. Calculate the average power output of his generator in kilowatts. So, in one day, the energy produced, which is energy is power times time, equals 1.8 kilowatt hours. What is the average power output? So the average power output means the power per hour. What's the average power per hour? So we're just simply rearranging this equation, all right, to get the average power. So we want average power equals 1.8 kilowatt hours divided by 24 hours. Average power per hour, which is not that. I did times by mistake. Is 0.075 kilowatts. So That's our answer there. So whenever it says average, often you divide by the total time if time's available. So that is the end of the energy exam questions.